Oh, so no. Hello, you nerds. I'm your pink mathematician, new guy on YouTube, and today's a very special day. I wonder why. Oh wait, it's my first video. And so first of all, why follow this YouTube channel? Well, I mean, you don't have to. I'm not gonna come and kill you or something. But if you have a genuine interest in math and you have the question why, then this is the right place for you. Because we're gonna answer the questions like, why is a theorem true? Like school, I don't think it really gives you the answer to why, a squared plus b squared equals c squared. You just accept it. But as any good mathematician would do, you would prove it for yourself. Because any mathematician or scientist is a skeptic. And that's how we built science. Because we were skeptics, we went out and, showed that it was true through scientific methods. And so we're going to show that for math. Math's not just about calculating and accepting formulas or memorizing formulas. It's about proving them. It's about creating new formulas if you go on to your PhD or whatever. And so that's what we're going to do in this YouTube channel. I was thinking, what proof could we do for like the first video? And it struck me, well, what better way to start a YouTube channel than to prove the Pythagorean Theorem, the most famous theorem in mathematics, I think. Arguably, I think so. And so we're going to do that. So get your piece of paper out and rewatch this video a couple of times if you need to. I'm not just going to give you the answers. As we get better and better proofs, I want you guys to also try to do it before watching the video, because that's going to really strengthen your brain. And so let's get in. Alright, so before we get into the proof, and before you ask why I have this list here, we have to ask, what is a theorem? What is a theorem exactly? Well, a theorem is something that is proved, something that we know is true, but we proved it. A postulate, something that we know is true, and we assume it's true, but we can't prove it. A lemma is a proof that we do before the main proof. So, for example, here I have the area of a triangle. If I were to prove that before proving Pythagorean theorem, that would be considered a lemma. Right. Yeah, so I gave you the definitions of what different types of aspects there are. And so how do we build a theorem? So how do we prove a theorem? We start with definitions and postulates. Then we play around with these definitions and postulates using logic and reasoning in logical order, and we'll get to a conclusion. So before starting this theorem, I'm going to give you a list of what you need to know. Now, if you haven't taken geometry, I guess you're screwed, and it's going to be a very sad day for you. But this is just, a list that of things you might not know, or you just need a quick reminder on. I'm assuming you guys all know all of these, maybe, I hope. So I'm just going to go through them very quickly. First thing you need to know before starting the proof, the area of the triangle. So this is also a theorem. I will prove that in later videos. You're also going to need to know the area of a trapezium. So this is a really cool way of proving the Pythagorean theorem. I know 3 ways to prove it, and so this video is just about the first one. So this is the area of a trapezium. This is if 2 co-interior angles add up to 180, then these two lines are parallel. Alright, so we have 2 right triangles between 2 lines. Those add up to 180, and so therefore they are parallel. We'll need to know the SAS postulate. We got into our first postulate. So this is just saying if you have 2 triangles and the corresponding sides are equal and the angle between those two congruent corresponding sides are congruent, if that is also equal, then the two triangles are congruent. So for example, if you have, let's just say a right triangle, two right triangles, and this are congruent. This and this are congruent, corresponding sides, and they both have a right angle here. They're equal. They are congruent triangles. That's basically what that's saying. For number 5, it's another postulate. So we say that if there are 2 points, there's one line through them. So 2 points determine one line. We know it's true. I think you know that it's true. We just can't prove that. The ruler postulate. Now the actual definition is kind of complex. I was looking at it in a textbook. It's pretty interesting. But essentially what this says is that you can take a line and you can put any point on that line as you please. So for example, if I have a line and I have point D, I can locate point D on any point on that line, since that line, can in one sense has an infinite amount of points. So I can just put a point there, or I can put it here, it doesn't matter. That's very important and very cool. The last thing you probably need to know is the area addition postulate. This essentially just says if you have 2 areas that are not overlapping, you can add those areas. And so we can't prove this either, but we know it's true. And so let's get into the proof. Alright, before we get back into this, I forgot to mention that there's a theorem that says that for every point on a line, there's exactly one perpendicular to it. I forgot to mention that. It's a theorem. We'll prove it eventually. But that's also very important. So you don't come shouting in the comments saying, Noah, bro, pink mathematician, you didn't tell me that. Well, now I'm saving myself. Alright. So let's start. Well, let's start with the statement of the theorem. So every theorem essentially has a statement. It goes like this. If something is true, then something. If you're given something, then something is true. So let's do that for the Pythagorean Theorem. If you have a right triangle ABC, a squared plus b squared equals c squared. So we're essentially given something that has been given, the right triangle, and we are given in the theorem, in the statement, that we have to prove a squared plus b squared equals c squared. And so this is how I do proofs, is that I always have a statement and then I have to have a reason for that. So let's start with the first statement. Well, the first statement is always going to be what's given. And so we can just put here right triangle ABC. Right triangle ABC. Well, what can we give that reason? It's given. That's the reason you can give. It's given. It's a given thing from the statement. We just put that right out. It's a perfect value. It's a good reason. 2. So if you stare at CA for a minute, we can come to the conclusion that any line segment is essentially part of a bigger line. A bigger line. That goes on forever and ever. And so on line CA. So for line segments, we just put a line on top of it. If it's a ray, it just goes in one direction. If it's a line, infinite directions. I assume you knew that. And so it's on line CA, locate point D such that BC. So what I just did is that I just located point D, the new point on line AC, such that BC, the length of BC, which is A, equals the length AD. This just requires creativity. Yeah, you just have to be creative and make that. And so what reason can we give this? The ruler postulate. So essentially we're just locating point D here so that the length is A. Right? Yeah, so that's what I did. And so what we can do here is that we can give the reason as ruler postulate. Remember, we can just locate any point on a line. Right, where's my eraser? Oh wait, no, it's a tissue. Anyway, so I'm scared that it's gonna go down here and you guys probably can't see down there. So I'm just gonna erase after every two. So I hope you wrote these down. Right, so after that, for reason 3 now, we can say, oh wait, erect a perpendicular from here, right? Erect a perpendicular. And so what we're essentially trying to do, spoiler alert, is that we're trying to make a trapezium. We're trying to make a trapezium. That's why I said there's, the area of a trapezium. So essentially what this proof is trying to do is make a trapezium out of right triangles. Add those areas, make that equal the area of the whole trapezium, and then use algebra to work out a squared plus b squared equals c squared. So erect a perpendicular is the next thing we want to do. So we just erected a perpendicular, and the reason is that it's a theorem. So for every point, there exists a perpendicular for it. The next thing we're going to do is that we're going to locate point E such that DE, the length of DE, equals CA, right? And so we're just going to put E right there. Let's go with the length of B. All right, so that's our whole thing. So locate E on perpendicular such that, such that DE, the length of DE, equals CA, essentially. That's what we did. Yeah, so we just did that, and I'm not going to give you the reason. You should try to find that reason for yourself. It's very similar to reason 2. That's what I'm just going to go with. I mean, no, it's the same. Right. So for the 5th reason is, remember we're trying to make right triangles? Well, one thing to do is just, boom. Okay, wait, that's not a straight line. Sorry, bro. That looks like a sector. Anyway, there. We connected A and E. So draw line. Okay, I'm not going to write line. I'm just going to do AE. Line segment AE. What reason can we give this? 2 points determine a line. Remember that postulate? 2 points determine a line. Right? So we just made a right triangle. So now we can look and see, oh wait, these right triangles are congruent. since this is perpendicular, it makes it 90 degrees. Now they don't look congruent. Yeah, don't ask why my artistic skills are very bad, but essentially mathematically they are congruent. By what postulate? So we can say that triangle ABC is congruent to triangle ADE. Well, if you look here, B and B are congruent, A and A are congruent, and between them the angles are the same. And so we can just say the SAS postulate. They're the same right triangles in size and shape. Right. So let's go with the 7th thing. Let's just connect these two to complete the trapezium. So draw BE. Again, I'm not going to give you this reason. Try to figure it out. And so we just drew a line BE. Now remember what we said early in the video. Well, crap, that looked more like an infinity. All right, 8. Right. So for reason 8, what we're going to do is we're going to prove that these two lines are parallel. And remember the theorem is that, well, line BC is parallel to, so that's the sign of two lines being parallel, and ED are parallel. By what theorem? Right? If co-interior angles add up to angles add to 180 degrees, then the two lines are parallel. They're parallel by that theorem. Right. So we've got into a pretty deep into this proof already. The diagram looks pretty different to what we started with. All right. So with the 9th reason. Well, if you look at it, we have angle 1 here, angle 2, angle 3, angle 4. How do you know that this is a right triangle? I know it because I proved it, but how do we know by proving it? Well, if these are 90 degrees and we know that, a triangle, the sum of the angles are 180 degrees, which is also a theorem, then angle 1 and angle 2 must equal 90 degrees, right? This is also a theorem I didn't mention, but essentially it's just saying that basically the two other angles that are not right, the sum of, so if you have two angles that are not right angles in a right triangle, the sum of those are complementary, meaning they add up to 90 degrees. So this equals 90 degrees. Since that is 90 degrees, we know that angle 3 plus angle 4 equals 90 degrees. What reason? Theorem. Angles add to 180 in a triangle. Reason 10 now. Statement 10. Right. So we know that because these two triangles are congruent, 1 and 3 are the same, and 2 and 4 are the same, since those are corresponding angles. And so what we can say is angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. Right. And so what reason is that it's the definition of congruent triangles. That's the definition of a congruent triangle. Same shape, same size, meaning all corresponding size angles are the same. Right, so what we can say now is that since 1 is equal to 3 and 4 and 2 are equal, that means that we can just substitute 3 for 2, 3 for 1, and say that these equal 190. And we know that on a line, the sum of the angles are 180. And so by algebra, this is 90 degrees by algebra. So hopefully you wrote that on a piece of paper and prove that for yourself. So essentially you just substitute 1 for 3, that equals 90. And we know that this plus this equals 180, and we know that that's 90. So we know that those two angles are 90, that therefore this must be 90 degrees. So we got now the right triangle. Now we get into the juicy algebra part. It's not too heavy. It's not as bad as proving the standard form of a parabola, but it's pretty fun to do. So what is the area of these two triangles? Well, the area of these two triangles combined, well, okay, the two areas are AB plus AB. So the area of ABC, the area of ADE, the sum of them. So that their areas, both of their areas, so the area of triangle ABC equals 1AB. Theorem, area of a triangle is half 1AB. Area of ADE equals also 1AB. Why? Because of the theorem. And so the area of BAE, the big triangle, is going to be half C squared. Since this is C, this is C, the area is C squared instead of AB. Okay. Right, so we can add these, right? So the theorem is that, the area of a triangle is half AB. And so here is where we get to the juicy algebra part. We say that half AB plus half AB plus half C squared equals, well, what's the total area? It's going to be, if you look for it, it's A plus B squared, since this is the height of the trapezium is BA, so A plus B, and the sides of the parallels, the parallel pair is also A plus B, and so multiplying those be A plus B squared. And so what reason can we give these? Well, it's two reasons. Well, the area addition postulate, so if you have non-overlapping areas, you can add them. And then you have the theorem of the area of the trapezium. So by algebra, you can just remove all the halves. And so essentially, well, 2AB plus C squared equals A squared plus 2AB plus B squared, right? By algebra. And if we transpose this over, this and this cancel out. And there we are. A plus B squared equals, boom, C squared. And it is a beautiful proof for the Pythagorean Theorem. Obviously, there's many ways you can do this. There are over 300 known ways to prove the Pythagorean theorem, and so this is just one of them. Well done! You just got through your first proof. It is your pink mathematician signing out. Stay tuned for more beautiful proofs like these.